So the first thing you're going to do for the GPP and NPP worksheet is you're going to fill out this chart. It says complete the following chart show your equation use once. So you see you have basically need to calculate what the NPP is. So that equation is going to be the NPP is equal to the GPP minus the respiration rate, or R. And since this is filled out on the table, it's really quite simple. You're just going to take, for example, here 15 minus 5, and you're going to get 10. And then you're going to do 25 minus 7 to give you 18. 28 minus 8 is 20, and then you're going to do that all the way down the chart. And then for the second chart, you're going to look at, you see you have food eaten, fecal loss, and then NSP. So you're going to do actually two equations. The GSP is going to be the food minus the fecal, so it's kind of like what the animal retained. So for example, you're going to do 15 minus 4 is 11, 25 minus 7 is 18, 45 minus 25 is 20. You're going to do that all the way down. And then for the NSP, you're going to do the GSP minus R, kind of like NPP minus the respiration. So it's going to be, you know, how much food do they retain minus how much do they use for energy. So you're going to do 11 minus 3 is 8, 18 minus 4 is 14, 20 minus 10 is 10, etc., all the way down the chart. Now, the calculating primary productivity can be a little confusing. It does use that factor label method, the kind of railroad method. It's unlikely to see this being calculated on the AP exam. More likely, you kind of need to understand what it's talking about. Don't forget that the GPP and NPP is all about how much carbon is produced through photosynthesis versus how much is left over after the animals use it and kind of pass it along to the next level. So it's part of that, you know, carbon cycling and how the carbon and energy goes through a food chain. So what you're going to do is you're going to take the unit that you're given. So in this case, it says how many milligrams per liter of carbon. So you're always going to try to figure out how much carbon is fixed from an ecosystem with an NPP of 10 milligrams of O2 per year. So basically you're figuring out, you're getting that much O2 out, how much carbon does that equate to? The reason you do this is you can't measure how much carbon is produced in a plant, for example, but you could measure how much O2 that plant is giving out. So this is an equation to kind of figure out what that difference is. So what I'm going to do is I'm going to start with what I'm given, and I'm given 10 milligrams of O2 basically was measured per liter. So I'm going to do 1 liter. I need to figure out what that is or what that converts to with carbon fixed. The first thing I need to do is convert that milligrams of O2 to milliliters of O2. That's going to be more helpful when we're doing the carbon. So one of the kind of conversions you're going to use is that 1 milligram of O2 is equivalent to 0.698 milliliters of O2. So remember that when you do this factor label method, you want to get rid of the one on top. So I'm going to put milligrams of O2 on the bottom, and that allows me to cancel out. And then I'm going to put 698 milliliters of O2 at the top. I'm going to do this math. So I'm going to get 6.98 milliliters of O2 per liter. That's how much milliliters of O2. Basically, I just converted it. I converted it from centimeters to inches or feet to miles or whatever that may be. The next kind of equation that you're going to need is that 1 milliliter of O2 is equivalent to 0.536 grams of carbon fixed. So for every milliliter of O2 you produce 0.56 grams of carbon. So essentially you're going to multiply it. So I'm going to take 6.98 milliliters of O2 that we just figured out per liter. And again, if I want to get rid of something, I put it on the bottom. So I put milliliters of O2 on the bottom. And then our conversion, 0.536 grams of carbon. I'm going to do some multiplication again, and I'm going to get 3.74 milligrams of carbon fixed. This should be milligrams up here. Sorry about that. Milligrams of carbon fixed. So what you're looking at here is, if you measure how much productivity comes out of an ecosystem, you can measure how much oxygen is produced, 10 milligrams. I used a couple of conversions to convert that to how much carbon is produced. And that tells me this is the amount of carbon produced in that ecosystem in that time. I'm going to tell you that these problems are quite difficult. It is extremely unlikely they're going to be on the AP test. So think of these more as challenge problems. So the answers are online. Try your best. Use the conversions up top here. These conversions are going to be really important up here. Try your best. If you don't do it in this factor label method, you just multiply or divide, that's okay. I want you to try your absolute best. Remember, don't panic or anything because they're not really going to be on the AP test. It's more that you understand the difference between, net productivity, gross productivity, etc.